So I'm guessing, because I ain't looked back through the videos yet, I've just whatever, I ain't looked back through. I'm guessing I got through wafting magnets past the windings, whether it's the windings that are wafting or the magnets that are wafting, stators and rotors in generators. And then you've got the supply cables, wires, supply lines coming out of the generators going to the consumers. And we have things like extension cables. Yeah, you know what extension cable is? It's like a spool of wire. One bit is stationary, the other bit spools, and the wire's inside it, and you pull the plug lead, and a lead comes out to the length that you want it. You plug it in the wall, put it on the floor, then you plug your consumer into the extension lead. Yeah. Now we all know that if you leave the extension leads coiled up, plug into the wall, it's a 30-meter extension lead, and you just plug it into the wall and put it onto the floor, and then plug something really heavy consumer into it, so like, you know, a 10 kilowatt consumer into a little cable that's all spooled up. After a certain amount of time, it heats up and sets on fire. So there's heat energy which is going through these wires all the time, and we just waste that. That's waste. Let's just waste all that heat. Yeah, you know, in a car you've got all these electrics going through all these consumers and whatever, and we'll just waste all that heat. You know what I mean? You could use that electricity, you could use that heat as heat for the car in the winter, in cold climates, and in the summer you could use that as potential difference. Because let's face it, when you're driving down the road, right, the bumper's cold because the wind's rushing past it. Some air vents are cold because wind's rushing past it, but the wires are hot because electrons are flowing through them. So now you've got potential difference, and any way that you've got potential difference, you can generate electricity. So we're wasting all that potential difference. So you've got heat loss, and then we've got flow waste, right? And what flow waste is as the electrons are flowing through the wires to the consumers and then to earth and back into the battery, you get flow loss. And what I mean by that is you've got a flux of electricity flowing through these through the copper wires, and they create a flux of electrons. It's electron flux, and it's constantly going through the when we get the spectral analysis bloody cameras, you'll see it going just pulsing through electrical. I posted a video a long time ago about pulsing electrons, but no one seemed to think it was anything serious, like, yeah, but it's a pulse of electrons, like, yeah, and they do the pulse just like a heartbeat. Alright, and as they go through the wires, we can wrap more wires around the wires and create more electricity. So you can take the heat for potential difference, you can take the pulsed electricity for the pulses, and you can regenerate off that, and we're wasting so much, it's unbelievable. And they reckon we're at like 97% in efficiency at the moment, but it's more like nearly 200% efficiency. We're over unity already, but we're just chucking so much away. And we've got the negative energies that we're just chucking away. That's 50% negative energies. We're chucking away waste, negative energy waste. Negative, and I'm at the end of the recording now, so I'm having to 354. I'm getting about 320s, 350s. So I'm going to have to take negative energy waste, put it on the next video, because this YouTube upload is crap and I can't be asked to do the editing, so I'm just putting it straight on. When I can be bothered, I'll put this video on later on tonight or some other time. I've got some other stuff to put on the internet as well. You know, so negative energy waste, energy waste. So that's like all the negative electrons we're just chucking away. All negative electrons just thrown away. Just throwing away. And by the time we've got all that, by the time we've got all those bits accounted for and used, then we're over unity. Because your alternator is running at a certain amount of kilowatts energy is used, kilowatt energy is put out. So it uses around about 5 kilowatts, and it puts out around about on a Volkswagen Passat 110 horsepower pumper diesel engine. If I remember rightly, they said it was around about 5-7 kilowatts. So it's 12 volts, and it's 110 amps, and we'll work that out. Virgins are rare. So we've got volts and amps, and amps times volts. How many watts are we getting on that? And I can't be asked to work it out in my head because I don't want to do no mental arithmetic. I want to use a calculator. Where's my calculator? There's my calculator. It's quite an easy sum. 110 times 12 equals, that's 1.3 kilowatts. So it's a negative energy of around about, I think it's 4 kilowatts it takes. Like it's a negative energy of around about 4 to 1. Yeah. There's 3 windings. There's 3 sets of windings. Alright, and you're chucking away half of 3 sets of windings. So you take 50% of that and put it together, and use the 8 winding system instead of 3 winding system, and I'm afraid you go over unity. Now I pump in to a flat battery power from a 45 amp alternator and stick that into a 110 amp motor, and the motor drives the alternator, and I bring that up to speed, right, from a flat battery. I'll bring that up to speed until the alternator kicks in and starts charging properly. Then I take the jump starter off the battery, and then it runs, and it runs, and it runs, and it runs, and it runs with admittedly some weird electrics. It's not set up as you would expect, like, yeah, it's some very weird electrics. But then that runs at over unity until the heat that builds up inside it creates too much resistance, and the process then shuts down. So if we take that wasted heat and the wasted flux energy and pump that back into the circuit again, maybe take the heat and the flux energy and put that into a refrigerant circuit, or run refrigerant through the wires, make them tubes, copper tubes, yeah, and run refrigerant through the tubes to keep it cool. In fact, let's put it in space. Let's put it in space where it's nice and cool, yeah, and run the engine up there and see if it works up there. And it does. We already know it does. That's why we've got nuclear fusion generators working now in France. Well, soon to be in France. We've got them in England, we've got them in China, I'm sure they're in Japan, I'm sure they're in America, and in many other places as well. But yeah, I'll have to go and get the drag coefficient of the alternator of the Volkswagen now to work it out exactly, because you're talking about 1.32 kilowatts it produces, and it's supposed to have sat around about 4 kilowatts, 4 or 5 kilowatts I think it was, around about that, yeah. But we'll see. And on these new alternators, they put a clutch on the front of the alternator to allow it to free, because when you're at 7,000 RPM or 6,000 RPM and 12,000 RPM and 5,000 RPM, when you bring your RPMs down to idle speed, the alternator is still capable with its kinetic energy to generate electricity. So they leave it generating until it slows itself down normally, then the engine takes it back up again, and you actually feel that when you're ready. You go, and you go afterwards again, like, as well, yeah? Which means it's still generating on its own with its flywheel effect, which means it actually takes less energy. It takes 3 kilowatts to get it up to speed, but once it's up to speed it doesn't take that amount of kilowatts out, I'm telling you. It's over unity already, and that's kinetic energy. They're using kinetic energy, we're wasting kinetic energy, waste kinetic energy. Energy.